All right, so this is page 130. This is what we did yesterday, so let's think about what we came up with from our little right triangle, right? We had drawn this right triangle, and we had this angle here, which was theta. This is our x, this is our y, this is our r, right? So we know that r is equal to the square root of x squared plus y squared. We know that the cosine of theta is equal to, cosine of theta is equal to x over r, but really what we were trying to get to is x equals r cosine theta. That's what I meant to write. Y equals r sine theta, right? And theta equals the tangent inverse of x over y. Okay, all that look familiar? Right, we had all that from our little triangle yesterday. And so these problems down at the bottom, we're not doing all of them. But we're going to do a couple of them, and we're going to plot them because I want you to see what's happening. But this is just what we did yesterday using this stuff here. So when I go to letter A, I guess there's not a number A. Example 1, letter A. 3 pi halves. This is in polar form. I want it in xy form, right? So my x is equal to 3 cosine pi halves, and my y is in 3 sine of pi halves. Make sense? So x equals, what is the cosine of pi halves? 0. So it's 3 times 0, x equals 0. Y equals 3 times, what's the sine of pi halves? 1. So y equals 3. So my rectangular coordinates for point A are 0, 3. Now let's go back up here. And we're going to plot the polar one first. They gave it to us. A is at 3 pi halves, right? So I go around to pi halves, and I have a radius of 3, counting by ones. 1, 2, 3. This is point A, and we're going to label it A. Then this point is a rectangular coordinate. So we're going to plot it like we normally do on the xy coordinate system. X is 0, so I don't go anywhere, and I go up 1, 2, 3, and this is point A. Do you see how they are in the exact same position? I even made sure that the grids are the exact same distance apart. So it should be, if I could, like take one and put it right on top of the other, they would be in the exact same spot. Just a different way to get to the same point. Make sense? Okay. So let's look at B. So for B, we're going to do x equals -4 times the cosine of 3 pi fourths, and y equals -4 times the sine of 3 pi fourths. And it's okay if you go into C because we're not going to do C. So x equals -4. What's the cosine of 3 pi fourths? Negative square root of 2 over 2. Oh, I can't write that. Negative 3 pi fourths. What did I do? Oh, right there. Dang it. 3 pi fourths. I think that's what I said, but I wrote a 3. Thank you. And then, so these two, when I multiply them, it's going to give me a positive number, right? So it'll give me a positive 4 square root of 2 over 2. What does that reduce to? 2 square roots of 2. So then y equals -4. The sine of 3 pi fourths is a positive square root of 2 over 2, which means y equals -2 square root of 2. So my rectangular coordinate is 2 square root of 2, negative, whatever that is. Yeah, we'll look at that. Don't worry. We're going to estimate a little bit. This is B. Yeah. And you're right. I get it that you don't really have a great estimate of that, right? This is why sometimes graphing in polar is better, because I'm going to have to estimate on that, right? Do I have to estimate on B in polar? No. I'm going to go to 3 pi fourths, which is right here. I have a radius of a -4, which is down here, right? So I'm going to go 1, 2, 3, 4. And I'm pretty confident my point is super accurate because I know exactly where the angle is and exactly where the radius is, right? To graph this one, we have to think about the fact that square root of 2 is about 1.4. So if I double that, it's like 2.8, right? So on the rectangular coordinate system, I'm going to go to the right about 2.8. And then I go down about 2.8, and I'd be right about there for my B point. Make sense? So that's an estimation. Well, I'm sorry, what? 1.8? Oh, that's 1 point. Oh, my Lord. Okay, you're right. I'm sorry. I'm stupid. That's 2.8. There you go. And then 2.8. Now it's right. Good Lord, have mercy. Okay, let's be. Plus, I should have been able to tell that. Oh, I didn't label this one. Those should be in the exact same spot. Should be. That one might be off a little bit because we estimated, but this one I know is 100% right, but they're in the same spot. We good? All right, let's go down to this one. We're going to write the rectangular coordinates in polar coordinates, and then we're going to graph. So here, I know that r is equal to the square root of negative 3 squared plus 3 squared. The negative doesn't matter. Good. So I get the square root of 9 plus 9, square root of 18. So what is that going to reduce to? 3 square root of 2? Let me show you why this one is so easy. Isn't this the same thing as 2 times 9? So basically this is like a 2 and a 9. So take the square root of 9, it's 3 square root of 2. It is 3 square root of 2. Okay, does that make sense? See how that works there? Okay. And then remember we have to take the quadrant into account here. What quadrant is this in? Negative 3, 3. Second. So it's in quadrant 2. And then so this is the r. I know that theta is equal to the tangent inverse of of y, which is 3 over x, which is a negative 3. So that's equal to the tangent inverse of negative 1. And that value in the second quadrant would be what? 3 pi fourths. I knew what you meant. 3 pi fourths. So my ordered pair here then is 3 square root of 2, comma, 3 pi fourths. Now, which one of these is going to be more accurate? My rectangular one, right? So on my rectangular, I'm going to go to negative 3, hopefully correctly, negative 3, 3, there's a point, and then I've got, yeah, it's negative 3, 3. Sorry, I have this bad feeling. And this is point D. Then over here, since 1.4 is about the square root of 3 over 2, or about the square root of 2 is about 1.4. When I multiply this, this becomes about 4.2. That's what we're looking at right there. So we go to 3 pi fourths, and we go to 1, 2, 3. What did I say it was? 4.2? Yeah, 4.2, right about there. And this is point D. Everybody good with that? You get the idea? Okay. So what I really wanted you to see, I wanted to review this, but I also wanted you to see how they are, when I say it's the same way, it's a different way to get to the same points. They're in the exact same positions, just a different way to talk about their navigation. Okay? We good? All right, so let's jump to the other then. Let's look at this. So this is going on page 131 now. And now we're going to convert equations, not just ordered pairs. And it says to recall this, which we just recalled anyway, x equals r cosine theta, y equals r sine theta. If you know that much, all you do is substitute that stuff in and clean it up. So right now, these are in rectangular form because I have x and y. So I have to substitute in the polar stuff. In place of x, I'm going to put r cosine theta. So r cosine theta equals negative 3. Now remember, I'm not solving for anything. I am trying to, well, I'm solving for r, but I'm not like solving to get a number or anything like that. So I'm getting r by itself. I divide both sides by cosine. So r equals negative 3 over cosine theta. What's the reciprocal of cosine? Secant. So does this become secant over negative 3? No, that negative 3 stays in the numerator. You don't have to rewrite it this way, but isn't this the same thing? Like, think about it that way. You don't have to write it, but you're taking the reciprocal of this, and that just stays where it is. So r is equal to negative 3 secant theta. And we're done. That's it. If I graph this in the polar coordinate system, it's going to look the same as this. When I graph this in the rectangular coordinate system, what is it? A line. Is it vertical or horizontal? Vertical. This is a vertical line. So is this. right? There you go. All right, so let's look at number 2. When I graph number 2 in the rectangular coordinate system, what is it? A line. It's y equals x something, right? Okay, so then if I want to kind of fix this a little bit, what I want is I've got x and I've got y, and I can make something out of them there, but I would think I would rather have it not have the fraction, right? So what can I do to get rid of the fraction? Multiply by what? 3. So let's just multiply by 3. The square root's fine, but let's multiply both sides by 3. So 3 times y equals x times the square root of 3. I wouldn't even have to do that necessarily, but I'm afraid that you might do some weird things if you don't. So now I'm here. And then I need to substitute, right? So if I substitute in for y, that's going to give me what? 3r sine theta. And that's going to be equal to square root of 3 r cosine theta. Everybody with me so far? Yes, because I had to substitute a y and an x. Well, it doesn't have to, but I did because the numbers usually do. I think it just makes a little bit more sense. Okay. Yeah, because it's still being multiplied. You usually put them at the end of those so as not to be confused about how far this little thing goes out. You know what I mean? Like, so if it's underneath there, but I could have left it at the end. All right, so I've got to solve for r, right? Somehow, but now I've got sine and cosine in here. What do we know? If I divide both sides by cosine, I'll have sine over cosine. Will that give me something? Yes. It'll give me tangent, right? So I'm going to divide both sides by r cosine theta. I'm going to put the whole r in there and everything. Because once I do that, what happens to r over here? It cancels out. And the r cosine theta cancels out over here, right? So this is 3 times sine over cosine. What is sine over cosine? Tangent. So I get 3 tangent theta is equal to the square root of 3. Well, it doesn't disappear, but it cancels out. Yeah. All right, so now I've got tangent theta. I don't have an r, but let's think about this. This graph's a line, right? When we graphed a line in the polar coordinate system, it either looked like that or it was just a theta equals something, right? So now I'm going to divide by 3, and I get tangent theta is equal to the square root of 3 over 3. So what does theta equal? Pi 6. And that's the line. That's why this gives you a line when you graph it. Make sense? Am I good? Yeah. So now you do. Yeah. It's a line. Because what this means is theta is pi 6 no matter what. Like no matter what the radius is, that's my angle. All right, so let's substitute this in here. I've got y, I'm substituting the r sine theta, right? And for x, I'm substituting in r cosine theta, but this whole thing has to be squared. Yes? Okay. So then I'm going to square it. On the left-hand side, I still have r sine theta. On the right-hand side, I'm going to get r squared cosine squared theta. Cosine squared theta. Okay, everybody with me on that so far? Any questions? Because the way you write cosine squared, like if I do this, it's the way you write it, because theta itself doesn't get squared. It's the cosine value that gets squared. So from the very beginning when we were doing that, that's where your cosine squared comes from. Okay? I mean, that's just kind of how the trig stuff is done. Okay? All right, so now let's look at what we have here. I've got r and r's on both sides, right? So I can divide this side by an r. If I divide this side by r and this side by r, those cancel out, right? So I get sine theta equals, what happens on the right-hand side? One of the r's cancels out, right? Okay. And so then that gives me, yeah, and you could substitute some, so I know where you're going with that. But I get r cosine squared theta. I want to get r by itself, so how do I do that? Divide by cosine squared. So r is going to equal sine theta divided by cosine squared theta. So that's not tangent in itself because I got a sine and I got a cosine squared, right? But isn't this the same thing as sine over cosine times 1 over cosine? Yes? Okay. So that means r equals what's sine over cosine? Tangent. And then what is 1 over cosine? Secant. And there you go. Okay. Everybody okay with that?
So it's okay to have two different.
It's fine. All right, we're all good now? Ask me a question. Okay, I'll let you look.
There's a street by my house.
Ooh. Are there other like other Greek alphabets? Just theta, just a random theta? That's funny. No, I don't live there. That would be funny though, wouldn't it? Okay, are we all good so far? I separated this because you can do that because I'm multiplying the fractions. That's different than if I was adding. Okay, we all good with that? All right, let's jump to number 5. So on number 5, I'm going to substitute in for x, it's r cosine theta squared, good, plus r sine theta squared equals 16. Now, if I graph this in the rectangular coordinate system, can anybody tell me what that's supposed to be? What is it? It's a circle. It's a circle equation. We learned it in geometry. Just saying. Whew. Okay. So this becomes r squared cosine squared theta plus r squared sine squared theta equals 16. Okay. So there's no dividing by r's on here, right? Because I don't have r in every single thing. But is it a GCF? Yes. So r squared times cosine squared theta plus sine squared theta equals 16. What's cosine squared plus sine squared? 1. So r squared equals 16. And what does r equal? 4. This is that simple circle that's centered at the origin, right? The radius is always 4. That's why you got that circle. This is a way better equation in polar than these things are in rectangular. Okay? We good with that? All right, flip it over. And let's see. We are, yeah, I guess we will do number 7. All right, so on number 7, well, actually, here's what we're going to do. We're going to jump down here. I'm going to do these because these are going to go quicker. I'm going to save this. There's not a crazy one on the quiz. I'm going to save this. We'll probably have to finish it tomorrow before the quiz so that you can finish the homework, but I want you to see these before we go. You'll be ready for the quiz, don't worry. So now we're going to convert in the other direction. So it said to do that, we remember that this is equal to x, this is equal to y. We have this. I really think it's better if it looks like this. To me, that's just because that's how we're usually using it. But it's the same thing, right? So if I want to convert the equations from polar to rectangular, I have r equals 7. Well, what do I substitute in for r? No, this. This is what I substitute in for r, right? Okay, if I graph this in the polar coordinate system, it's a circle. I substitute this in for r. So r becomes the square root of x squared plus y squared. That equals 7. How do I get rid of the square root? Square both sides. So x squared plus y squared equals 49. That's the equation of your circle. Bam. That's it. That's it? No, these do not. No, these do not get harder. The ones up at the top are a little bit. They're not harder, but they're weirder. These are all very easy. Okay. So then, number 10, right? Theta. Well, the tangent of theta equals y over x, but remember, theta is equal to the tangent inverse of y over x, right? So to substitute in for theta, I'm going to substitute in tangent inverse of y over x. That's equal to 2 pi thirds. Well, if I need to get x and y out of that tangent inverse, what's the opposite of the inverse? No. Reciprocals and inverses are two completely different things. No. But the inverse is the opposite of tangent, right? So the opposite of the inverse is tangent. Yes? So if I take the tangent of both sides, this gives me y over x, and this equals the tangent of 2 pi thirds. Oh, if I can write 2 pi thirds. What is the tangent of 2 pi thirds? Square root of 3. Is it positive or negative? It's negative. Okay, so I get y over x equals negative square root of 3. That means y equals x, well, I guess we'll put square root of 3 first. It doesn't really matter as long as your square root sign isn't crazy. Negative square root of 3 times x, and we're good. That's it. Okay? Everybody okay with that? Ask me questions if you got questions. I just multiplied both sides by x to get that y by itself. That's all I did. All right, so now let's look at 11. I've got r equals 3 secant theta. So what do I substitute in for r? Do I want to substitute anything for r here, do you think? No. I want to make this like a cosine thing, right? Isn't this r equals 3 over what? Cosine theta? Yeah? So if I multiply both sides by cosine theta, I get r cosine theta equals 3. What do I substitute in for r cosine theta? X. X equals 3. X equals r cosine theta. Don't make it harder than it is. Right? All right, so now r equals, what's the reciprocal of cosecant? Sine. Negative 2 over sine theta. So now I'm going to multiply both sides by sine. I get r sine theta equals negative 2. So y equals negative 2. Okay. Now I will tell you, these two require completing the square. So we're skipping those. But we do have enough time. Dang. All right, we'll do it, my Lord. He was very upset. No. Okay. All right, so we do have time to do these. I think I'll do number, I think I'll do number 8 because it looks like it's a little scarier. Okay, so we've got, what we need to do here first is we need to multiply this out, right? So these are special cases. Basically, remember, this is not, this is not x squared plus 4. This is x minus 2 times x minus 2, right? So that means that's going to give me x squared, and then minus 2x and minus 2x, that's minus 4x. And then negative 2 times negative 2 is a positive 4. Okay, if you have to go off and, do that and make it, I'll write it all out, that's fine. We're just not going to take the time to do that. FOIL, yes. And so this is y plus 1 times y plus 1, right? So this is y squared plus 2y plus 1, all that equals 5. Yes? Okay, so we are going to, well, in just a second we'll substitute. Let's clean up these numbers first, right? Yeah, this 4 and the 1 is a 5, right? And if I subtract 5 from both sides, doesn't that just become 0? Yes. All right, so we're going to get x squared minus 4x plus y squared plus 2y equals 0. So far not that bad. Like, it looks kind of yucky, but it's really not as bad as you might think. Okay? We good so far? Okay, so now we substitute. And remember, for x, we substitute r cosine theta, right? So this is going to be r cosine theta squared minus 4 times r cosine theta plus r sine theta squared plus 2 times r sine theta equals 0. So there's a lot of writing, but it's not bad, right? Oh, get over yourself. It's not that bad. Okay. So here's what we're going to do. We're going to take the r cosine, so this is going to be r squared cosine squared theta, I'm sorry. And then, so I've done this one. Then we're going to put the other squared next to it, this one right here. So this is going to be plus r squared sine squared theta. Since these are both going to, or since this was negative, we're going to move it over here, and this is going to be the positive 4r cosine theta. And then when I move this one over to the other side, it's going to be minus 2r sine theta. I'm running out of room. And here's why I'm doing it like that. Because I put the squares on one side and the not squareds on the other side. I've got GCFs. GCF, r squared.
Students, don't forget, biology star tutorials start right at 2:40 and they run until 3:25 today. The more you come, the more chances you have at winning the grand prize giveaway. Have a great evening. We'll see you back here again tomorrow.
All right, so I don't want to rush this too fast. I mean, we still got a couple minutes, but do you understand where everything came from so far? I had the GCFs on both sides, right? Let me back up. Go ahead. You could, but it's going to make it more complicated sometimes. I did. 2r sine theta. Oh, yes, yeah. You can. But yes, so it wouldn't really matter either way because you're going to cut. Yes, so yes, I'm sorry, I wasn't sure what you. And so since I didn't, I'm not going to change it, but yes, I probably should have. What's this become? 1. So this is just r squared equals r times 4 cosine theta minus 2 sine theta, right? So then can I divide both sides by r? When I divide both sides by r, I get r equals 4 cosine theta minus 2 sine theta, and I'm done. What do you think about that? Oh, you love it. It was so much fun. Okay, we're going to omit some on the assignment, so make sure you're paying attention. You're going to omit 10, 15, and 16. And it starts with number 9, so 10, 15, and 16. 10, 15, and 16. 10, no. 10, 15, and 16. Mark them out right now. 10, 15, and 16. All right, have a great day. Get out because I have a department meeting.